All right, class, we're down to the last part, or the last little thing that we need to learn from 9-5. And this actually looks very similar to what we were talking about before with the three previous theorems. But this theorem is actually going to be a slightly bit different the way it's written. It talks about the triangle angle bisector. So all this is saying that is, let's first look at this giant triangle J to K to L before you start seeing these individual red and blue parts here that seem to be a little bit different. This is all originally one triangle. And what happened here was we constructed a angle bisector in this corner of J, or KJL, basically, in this corner here. So we have an angle, and then we constructed the angle bisector, JM. Now, instead of making an actual proportion with JM with any other angle bisector, notice that we're only looking at one triangle this time, whereas before, you were looking at theorems comparing two different triangles. Well, here we're talking about within one triangle if you create the angle bisector. So what's interesting is we're not talking about two different triangles. We're talking within the same triangle. If you create an angle bisector, what's really funny about that is that you can kind of see that KM and LM kind of make some kind of proportion. They're not exactly equal. I did not say that they're equal because an angle bisector by definition does not make the opposite side for which it starts at the vertex here. It hits the other line opposite to that angle for which it bisects, which is KL. It does not intersect or bisect KL in the two equal parts. That's not what's happening. But KM and LM do make a ratio. And what's funny is that on the other side of this angle bisector, the segment that is, let's say, I guess, vertical to JM, the angle bisector JK, is actually can also make a ratio comparable to the other side that is on the bottom vertically of JM, JL. In fact, if you compare the ratios JK to JL, it would equal or be proportionate to the ratio of KM to LM. So that's why it sort of makes two comparable, almost mini triangles, if you think about it, in this larger, overwhelming JKL triangle when you construct this angle bisector in such a way that KM and LM will make a ratio that is proportional to JK and JL. So what this is going to look like is a problem that looks like this. It's going to be pretty tough. Actually, let's just go with the book, actually, without going into too much detail. I'll give you my crude drawing. So this is basically a similar situation where you need to find X in this triangle given only one thing, that you know that TR is going to be the angle bisector. It bisects the angle R. So it bisects the angle R to the other side of QS. So basically what this is saying is I know that the ratio of SR to QR, or QR to SR, doesn't really matter, 14 is 6, 14 divided by 6, or 6 divided by 14, that will be the same as if I compared the lengths of QT and ST. But notice the trick here is that we're only given the length of QS, the whole thing, instead of just TS. We need only TS, but we do have QT, and we have QR and SR. So we want to compare how SR and QR compare in a ratio and set that equal to the ratio of ST, the bigger part again, to QT. But again, we only have this larger side 18. So how do we solve for this type of problem? Well, let's kind of revert back to my drawing. It's not quite as eloquent, but it's the same model, so it's kind of nice to see that. So let's write that out. I know because of this angle bisector, RT, it cuts this into proportional sides in such that you'll have you'll have a ratio between two corresponding sides, SR and QR, and they will be proportional to another ratio of the other two corresponding sides, ST or TS. I'm sorry, if you want to do it from TS to TQ or QT. Okay. Now SR, not a big problem. We have 14, and then QR is going to be 6. And TS is what I don't have. But let's see. T to Q, I do have it, which is just X. But what is TS? Okay, well, if you think about it, this whole side length is 18, and I only want to find TS, so basically I would have to take this whole side length 18, subtract QT from it, and whatever's left over is TS. So that means I take the whole side length of 18, and you'd have to subtract X to get whatever TS is. So essentially what I'm saying is TS is the leftovers of 18 minus X, or basically TS is equal to the whole thing QS minus TQ, right? Which is, again, QS, the whole thing is 18. This little segment here is X, TQ, so 18 minus X. This is basically what I really need. And what I'm going to do is I'm going to put that right here, because I know that TS is equal to 18 minus X. In place of TS, what I don't know is I'm just going to write 18 minus X. There we are. So now, to solve for X, you simply just have to cross multiply. And remember, if you really think about it, by the way, okay, I'm still looking for TS, not just X. X will help me to find TS. So just keep that in mind, okay? So anyways, let's cross multiply. We have 14 times X, and then we have is equal to 6 times 18 minus X. Then we'll do the distributive property between 6 and 18. I believe I did that correctly. That should be 108. So 14x equals 108 minus 6x. Okay, off to a good start so far. And then we're going to add 6x to both sides, so that way I can have all my x's on one side. I have 20x is equal to 108. Then I will divide both sides by 20 to solve for just x. X will be equal to 5.4. You can punch that in your calculator. Remember, that's not the final answer. I'm not just solving for X. So I know now that QT, at least, if I go back, I knew that QT was literally X long. So if I knew that QT was X, QT, in the case that we solve for X, QT is literally, or is 5.4 units long. Great. I also want to find TS. And remember, I have determined that TS would be the whole thing 18 minus whatever QT was, which is X, and we know X to be 5.4. So if we continue on this route, it'd be 18 minus 5.4, which should give us approximately, what is that? What is 18 minus 5.4? I believe that is 12.6. I believe, yes, it should be 12.6 TS, okay? So actually, I took this from the book, and the book is actually find X. So I guess we took it a few steps further. We found X, that was 5.4, not a big deal. Then we just took it one step further. QT is equal to X, that's 5.4. And we also know that TS is equal to 18 minus X, which is 18 minus 5.4, because we found 5.4 to be X, and we got 12.6. Okay, guys, that's the end of this, and you guys are all good to go now. Okay, so good luck, and have a great week.